In this video, we're going to be building a semantic search application. This application will allow the user to upload a file and then send prompts to ask questions about the information in the file. For this application, we're going to be using LangChain, and we're also going to be using Chorma to store the embeddings that we're going to create about the text. We're going to be using Python. If you don't have Python, you can download it from python.org. I'm also going to be using Visual Studio Code, which you can download from code.visualstudio.com, or you can use your preferred IDE as well. We're going to be using Streamlit to build the UI, and we're going to be using the OpenAI API so we can use the embedding API and the completions API. So we're going to need a API from OpenAI for this application. So let's take a look at this diagram here to have an idea of how this application is going to work. When you first look at this, it looks a little bit complicated, but a lot of these steps are very easy and straightforward. So basically, your user is going to upload a file. This is going to be the step one. The file is going to go into our app. We're going to take this file. We're going to, of course, load it. And then we're going to load this using a document loader from LangChain. Then from this file, we're going to split it and create chunks of the text. And then each chunk, we're going to create a embedding or a list of numbers that are related to some category that the model knows about. And we're going to store those embeddings, so this list of numbers, into a vector store. Now, for the second step, the user then, after uploading the file, they're going to send a prompt to ask questions about the file. This prompt is going to go into our app. We're going to be using a retriever to create a embedding about the prompt. So using this embedding, we're going to do a similarity search into our application for our embeddings. And we're going to retrieve the embeddings with the closest similarity search result to the prompt that we have. And then we're going to take in this chunk of text or this embedding. They could be 1, 2, depends how many we want to retrieve. And then we're going to use that embedding in order to pass it together with the prompt and create a chat prompt template. Now that we have this prompt template with the prompt and the embeddings, we're going to have this augmented prompt with the information that we need for the model to answer our question. So we're going to pass that to the model. The model is going to give us back the results or the completion, and we're going to render that into the application. So this is the flow of the application here. Again, a lot of the steps are like 1 or 2 lines of code. They're pretty straightforward using LangChain. So let's build this together and see how this works. All right, so let's create a new project directory. Let me just move this to the side. And I'm just going to create it here on my desktop. So I'm going to right click, new folder, and create a folder called Semantic Search Engine. And we're going to open this folder with VS Code. So I can click on more options, open with code. And if you don't have that option, just open a new window, a new VS Code window, and then go to File, Open Folder. You can find the folder from there. Now let's put this side by side so I can move this more freely. Cool. Now in the extension tab, you need to go and search for Python. We need to have the Python extension open in here. So just click install here so we can use this extension in order to work with the project. After that, just go back to the file explorer here, and we're going to create a new file called requirements.txt. Requirements in here, hit enter. Make sure it's a txt file, and I'm going to paste all the dependencies that we're going to need. So you can pause the video here if you want, or find the file in the source code and copy and paste it in here. So here we have all the dependencies that we're going to need: Streamlit for the UI, .env for the environment variables, the LangChain main libraries here, the LangChain OpenAI, LangChain text splitters, and the LangChain Chorma in order to store the embeddings. Now we can close that up, and we can now create our environment variable by clicking Shift Control P. So we can bring up this palette, or you can find it in the menu up here. And then in here, search for Python create environment. I can see it in here in my recently used, but you have to search for that in here. Once you find it, you can click on this, then click on the first option, v.env, to create our virtual environment. Pick your latest Python interpreter from there, and then we're going to select this requirements.txt file and click OK. Now this is going to create the virtual environment for you. It's going to install all the dependencies that we need, and we'll be ready to go right after this is completed. So I'm going to pause here and continue as soon as this is done. All right, so the installation and the virtual environment process is completed here. So now let's create a new .env file. And this is where we're going to create our OpenAI environment variable. So OpenAI API underscore key. So we can store the API key here. So no spaces in here, just an equal signs. And right next to this, we're going to paste the API key. So let's go into platform, go to platform.openai.com and click on API keys. So you can create a new key for your project. As you can see, I already have one for this project. So I'm going to use the same one I have here, and I'm going to paste it right here without any spaces in there. So it's going to look like SK, some numbers in here. It's not in uppercase. It's going to be like lowercase here, some number in there, right? So I'm going to paste it in there, and I'm going to continue. So I'm going to pause here and then continue. Cool. All right, so I got my environment variable ready in there. Now I'm going to create a new app.py file so we can start building the application. First thing we're going to do, we're going to import Streamlit. Streamlit as st. And then here we're going to do a quick st.title, and we're going to say Semantic search engine. There we go. And let's also put a header, st.header in here, so we can build some of the UI and say upload a file to get started. And then we're going to open up a new terminal here. You can open a new terminal by clicking here, terminal, new terminal. Already have one open here. And then we are going to run the Streamlit command to run the application and see if everything is loading correctly. My terminal is still loading. Okay. And let me resize this a little bit here. All right, so down here, I'm going to type Streamlit run app.py, and this is going to open a new tab on my browser here. There we go. Cool. Let's add a little divider here. So comma, divider, and then say green. Once I save again, you're going to have the option on the top right that says always rerun. If you don't see it, it's because it's under my video here, but it should be there. And now every time we save, it's going to reload the app for us. Perfect. All right, let's do a little bit of just another UI element here. So in Streamlit, you have all of this different, in the API reference, you have all of these different methods that are going to give you these widgets for text, for showing different graphs, data elements, you name it. They have everything in here built in for you. So the one we're going to need right now is going to be one for uploading a file. So we're going to use the sd.file uploader, and here we're going to say select a file in here. Go ahead and save it. Select a file, that's fine. Cool. So the file, the user can click on browse or just drag and drop, and we're going to store that into a variable here. We're going to call it uploaded underscore file equals to whatever file the user drops in there. Now, once we have a uploaded file, we're going to start processing the file. So let's hide the terminal so we can have more space. We're going to check if uploaded file is not none. Then we want to do something in here. The first thing we want to do in here is to basically load the file in memory, so into the application, so we can store it in our app. So let's do a with sd.spinner, so we can show the user that we're processing the file. So let's just say processing file in here, and then colon and enter. Let's do a try statement in here. Let's do pass for now, and then here an exception, accept exception as E, and here we're going to just print E for now. Let's go back up here, and in here let's print some information about the file. So let's say print and say file info, so we can see what information we have, and say uploaded file, so we can print that up in there. Cool. So now let's open our terminal so we can see the console log, and you can click browse file, and I'm going to select a file about responsible AI in education, but you can upload any PDF file right now, or just find the link in the video description. So we can upload the file, and we see the information about the file in the terminal. So we see our console log, file info. It says we have an uploaded file, and there's a file ID, there's a name, and there's a type, there's a size, and some file URLs in here. So let's use the file name to store that into a variable, so we can use that as the path to kind of like upload and store the file in memory. So let's say save file in memory, and then here we're going to create a variable called temp underscore file underscore path. We're just going to store the uploaded file, that name, so that's what we're going to be using. So the name right now is just this here, responsible AI in education.pdf, and we're going to use that name to open the file. So we're going to say with open, so use the open method, and then we're going to pass it the temp file path name, and we're going to pass WB for write binary, so we can have access to the file, and we're going to say as F, and then we're going to hit colon, enter in here. So from the file now we can just call the .write function, and we can pass the uploaded file, and then we can call the .get buffer function from there, so we can store the file in memory. So once I'll save the file, you can see the file is already saved in our application. We can delete that later from using the OS module to delete the file here later on, but that's fine. We can keep it in there for now. Now, the next step is to load the file with the with LangChain. So we're going to use, let's say, PDF file loader in here. So for that, we're going to have to import some components from LangChain. So let's go all the way to the top. And let's say here, we're going to import this from LangChain community. So we're going to say from LangChain community dot document uploaders. We're going to import the py PDF loader here. Cool. And now we're going to go back down to this comment here, line 26, and we're going to load up, let's create a new instance of the loader. So let's say loader equals to py PDF loader. And now we need to pass the temp file path, which is basically the name or the path to this folder file in here, the responsible AI PDF file. And then we're going to just load up the data. So we're going to say docs equals loader dot load, and then we're going to print what docs is. Let's put a comment here. Let's say docs in here, and I need a comma in here. There we go. So it says that we need to install the PDF package in here, which is required for using this. So yeah, we're going to Control-C on the terminal. We can just run this pip install here, right? So we can copy that command right there. This here, Control-C, paste it in here, press enter there. And we can also add that to the list of requirements because this is required for the uploader. And normally if you have another one, LangChain will let you know what other packages are required to install that. So you can list it in here as well if you want. So we're gonna go ahead and run the application again to see if everything was installed correctly. Okay, so let's select the file one more time. So here, let's select this one. All right, there we go. So now we got some data in here that we can see. So let's scroll all the way to the top. You see docs in here. We have a list of a document instance here. There's some metadata, some information about the file. And then we have this other metadata there. All of this here. Then we have the page content here, which is information, the text in here. And all of this is text, all the way in here. There could be another document here if it's a different page, right? So we got a few documents in there, page 1. And then there's some more down here. But basically is loading up all the information in there. And sometimes it doesn't show everything because in the terminal it doesn't show all the text, but it's pretty much loading all the information about the PDF file. So cool. So we have that there. We could comment that out. That was just for testing. We don't really need to see that every time. So now the next step we're going to do is that in this big documents that we have, which might contain a lot of text, we want to create chunks for these part of the text. So let me show you the diagram again. So we basically are uploading the file here in the document loader here. Now we need to create these chunks, and then we're going to calculate the embeddings, and then store the embeddings in the vector store. So let's go ahead and create the chunks here. So we're going to say create chunks in here. Now, in order to do that, we're going to use a text splitter. So we installed the text splitter already in the requirements. So we just need to import it. So we're going to scroll all the way up, and we're going to import that, say, from LangChain text splitters, import, and then we're going to use the recursive character text splitter in order to do that. Then we're going to, let's hide this for now, go in here again, and we're going to create our text splitter in order to split all the documents. So here, we're going to say chunks equals, and then we're going to do, let's create the text splitter first. Let's see if we should do it here, or we could do it at the top. I think we can just initialize the text splitter here. We can also do it here, but then here we're gonna have too much code in there. So let's do here, this is gonna be our text splitter. Let's say text splitter. It's going to be equals to the recursive character text splitter, and then parentheses, and hit enter there. Here we just need to select a chunk size, so how big our chunks are going to be. So chunks underscore size is going to be equals, let's say, 1,000 characters, and then we're going to have a chunk underscore overlap of 200, and we're going to say add star underscore star, star index equals to true, capital T, true. Cool. So we basically are creating this recursive text splitter, and we have the text splitter here now initialized. Our chunks are going to be 1,000 characters long. There's going to be an overlap of 200, so we can keep the kind of like the context of the just in case one document is going to look into the chunks that it's creating, and you're going to have an overlap of 200, so we know the context from each of the other chunks, so we can keep that context a little bit better. So we're going to use this text splitter down here to say text underscore splitter that, and then we're going to call the split method or split document. So split documents, and we're going to pass our docs that we have uploaded in here. Now we can have a print statement here just to double check that everything is created. So let's say chunks created, and then let's just do let's say length of chunks, and let's click always rerun here again so we can look at the terminal. It looks like we got an error here. Chunk size, do you mean chunk size? Okay, so it looks like this is without the S in here. There we go. We saw the process in there. It looks like we created 50 chunks in here from this document. Cool. So that we're getting our chunks created in here. Now we can see each one of these chunks or see how big they are. So if we want to get some more information about that, we can do a for loop in here. So for I, comma, chunk, we're going to use a in enumerate to pass our chunks in here. And then we need colon. And then let's just print a f string. So f quotes, and let's say chunk, curly brackets I. And I'm missing a T here for print. Chunk I is of size, and then let's do a comma, length, curly brackets, chunk. So we're going to grab each chunk, we're going to do that page content. So we're going to see how big the chunks, or how many characters are in the chunk that we created. So if we save that, we see we have all the way from 0 all the way up to 49. And we see that these chunks are different sizes, right? We have a chunk of 982. This one is 1,000, so there shouldn't be greater than 1,000. The last one is 717. And in here, we can just see the size of each chunk that we created in there. Right, it's just to show you the different sizes in there. We don't really need that information too much, but we can keep it in there so we can see if we upload different files, see how many chunks we have. And now we can move to the next step. So we are in here now. We create our chunks. So what is the next step? The next step is to work with the embeddings. So now that we have this 50 chunks, we need to create 50 different embeddings and store those embeddings inside of the vector store. So we're going to go all the way to the top, and we're going to import from LangChain, OpenAI. We want to import, so we need to import two things. We need to import the, let's say, import the, OpenAI embeddings. And we also going to need the chat OpenAI for later, but we can just import it now. And up here now, or down here, we can create our, let's say, embedding model, and embedding model, and we're just going to call this embedding model underscore model equals OpenAI embeddings, and we're going to pass parentheses and then model equals quotes, and we're going to use the text dash embedding dash 3 dash large. Right, you can look into the documentation on OpenAI to learn more about the different models, the different embeddings in here somewhere. So they have the check completions, and they have the embeddings API here. You can read about the different models they have, the pricing, and select the one that you prefer. There are some different models you can use, different pricing, but they're pretty cheap, and they are just probably cents for a good amount of embeddings. But double check the documentation there before proceeding, of course. But if you have like the credits, that is more than enough, or like the free credits they give you, that is way more than enough to complete this and continue with the application. Now, okay, so we have the embedding model in here that we need. So with this embedding model, we can now create embeddings. So let's just create a quick embedding here just so we can demonstrate that in here. So in here, we're going to create embeddings, and let's say just AV1 here equals, and then we're going to use the embedding models that we created, and we can call the dot embed let's say embed documents, or there is a embed query in here that we can use. So this is going to call out the OpenAI embedding endpoint for embedding query text. So we can call that, and we can pass the, let's say we're going to select the chunk square bracket 0. So the first chunk in there. Now we can print how this looks. So we can print our embedding 1, and let's just hit save. Check the terminal, scroll all the way to the bottom. We don't need this much space here, so let's just give you more space here. So in here, we're getting this embed 1 argument document object cannot compare it to by string. Let's do okay, because I'm doing first embeddings, I need to do embeddings dot page content, so we can actually grab the text to create the embedding. So now if we save it, in here we're gonna see the embedding right here. So this is the list. So there's a really large list of numbers, right, that you have available there. So you can read more about the different parameters or the different dimensions that you have available for the OpenAI one. There's a lot of information in there that you should read and get familiarized with. But right now you can see that this is a list. It's a long list. It doesn't print everything here, showing you the embedding that was created for the first chunk of text. So we can scroll down and we can actually comment that out. And actually just comment both of these lines out because that was just a quick test. Because we really want to combine this embedding model with our vector store. So instead of doing it separately, we're going to create a new Chorma instance and pass our embedding models to use to create the embeddings and store everything in the Chorma database right away. So in here, we're going to go all the way to the top again. And we're going to say from LangChain Chorma, let's import Chorma. And we're going to go down here and we're going to say this is our vector store. And we're going to create a variable. We're going to call it, let's just call it Chorma underscore vector underscore store. Set that equals to Chorma parentheses and hit enter in there. Now in here, we need to pass a 3 options in here. We need to pass a collection name. And we can call this, you can call this whatever you want. You can call it, call this my docs underscore docs if you want for our documents that we're uploading. And then we need to set the embedding function to our embeddings model. So it's going to use our embedding models that we pass in here. So our OpenAI embedding model is going to be used to create the embeddings right away. And then we need to pass a persist directory, and we're just going to say /Chorma /db for the option for our persist directory to store or to basically where to create our database. So now you can see once I save and the app refresh, we can see we have this Chorma directory and we have our DB in here. And Chorma is a SQLite open source database that we can use in here. So we have our database already created here. And now we can go back down to creating our embeddings. And now we're going to not just create our embeddings, but we're going to basically index our embeddings. So we're going to create them and store them in a database. So we can say in here, so we can keep that there. We're going to say index embeddings in here, and we're going to say, let's say Chorma underscore IDs, because we're going to get some results in here that we want to console log, and we're going to call our Chorma vector store that add documents method, and we're going to pass in documents. We're going to set documents to our chunks that we created in here. So our chunks that we created here using the text splitter is going to be passed to this one here. This here is just to show you how to create a simple embeddings. You can remove this in here. I'm gonna keep it there just in case we need it. We need to go back for reference, but basically this is all we need in order to create the embeddings. Remember, the Chorma vector already has our embedding model already passed as an option to the model that we want to use to create the embeddings, and it's going to index those embeddings inside of the database that we created here right away. So now in here we can do a quick print statement and say Chorma IDs in here, whoops, and then pass the Chorma IDs, and we can see it in the terminal. So let's wait for this to be created. Chroma's IDs. So here we have a bunch of IDs for the different embeddings that we created, and as you got a typo in there, but basically this is all we get back the IDs of the embeddings that were generated inside of our Chorma database or vector database in there. Cool. So let's just fix this typo here. Chorma. There we go. Let me not save the file just yet. Let's just review a little bit of what we have here. So we can upload the file to the app. The app is going to go to the LangChain document loader. We use the text splitter to create different chunks. Now we're using our Chorma instance to use the OpenAI embedding models to create the embeddings and store those embeddings inside of the vector store. Now we get back a list of IDs that for all the embeddings that were stored in the vector store. So we're basically done with the first step in here, which is basically processing the file. We create the embeddings, we store those embeddings. Now we need to let the user create a prompt, and then we're going to use the retriever to go and retrieve a similar vector or embeddings that is similar to our prompt. So we create from the prompt, we create a embeddings, and we're going to match something similar to that and return maybe 1 or 2 documents, and then continue with creating a chat prompt template and sending it to the LLM. All right, so let's see this here. So now that we have our embeddings created, we're going to use a retriever to go and we have let's say this is from the LangChain documentation. So in here we have some text, we created the embedding. Now we're going to do a similarity search in order to find a embeddings that is similar from the embeddings that we have stored in our vector store. So from the prompt, we create a new embedding. We're going to find the most similar one that we can find, and then we're going to retrieve that document. And in order to find the most similar one, we're going to be doing a similarity search using a retriever. So right after creating the embeddings and storing the embeddings, we're going to create a retriever. And to the retriever, we're going to set that equals to, we can create a retriever from our Chorma vector store that as a retriever. And then here we just need to pass the options for the retriever. right? So we're just calling that method directly from our Chroma vector store that we're creating. So we're going to set this search underscore type. So what type of search we want to do? We want to perform a similarity similarity. That's it. That's all we need to put. And then we're going to do this search underscore arguments in here. So kw args, and we want to set that to a dictionary with k colon, and then how many documents basically we want to return. So the keyword arguments to pass for the search that could be included up in here. So you have different options in there, but we're just going to pass, let's just pass one. So we can retrieve just one from, which is going to give you the closest one in there. So if we pass like 2, we'll give you back 2 embeddings, if 3, and depending on the score, the closest one is, of course, the first one, then the second one, and third. But if you just pass 1, we're going to get the closest one that we can find. So you can play around with how many embeddings you want to retrieve in this option here. Now, before we go in here, let's just take a quick step back just to see how this is, because the retriever is super helpful to use, but you can do it even before without the retriever. So if we go in here right before this, let's say Similarity Search, we can do a quick similarity search in here with a different method. So we're just going to say results equals, and then we will use the Chroma vector store that Similarity Search function. And then here we can pass a string. So let's hit enter here, put a string, and pass the prompt, right? Like, what's the question? So we're going to say, what is the main topic of the, let's say, basically what I have here. Let me show you the document. So in my downloads, let me just show you what this responsible AI PDF file is all about, so we can have an idea. I'm just gonna show that for now. So this is the file that I've been using. This is just a case study about responsible AI in education, right? So I will make sure to drop the file, the link to the file in the video description, but you can use any PDF file that you want to upload and try it out. So I want to ask a question. I want to know what is the main topic of this case study, right? So let's close that up and let's say, what is the main topic of the case study, right? Because the user knows what they uploaded. They just want to extract information from the file. So I'm going to do that and print the results in here to see what we get. Let's open the terminal up again. And let's see what we have in here. If we scroll back up, this is our Chroma's ID. So the result is this here, right? I forgot to put a comment at the beginning, but basically this is the document or the chunk that is the most similar, that makes more sense to use in order to answer the question that we just asked. So if we look at the page content, it says analysis as a alerting mechanism, and this system enables, let me see, in here, there's still a lot of information here, right? But it looks like this is the closer or the more similar information to the questions that we're asking. So let me see. To mitigate bias. Okay, so it talks about mitigation bias inside of this case study. There's a lot of information in there. Let's say personalization in education, learning system in edtech, to leverage AI-based recommender system to tailor. Okay, so it looks like this around here, probably the main topic of the case study. So we have retrieved the most similar embedding to the embedding that was created from the question that we asked. So the behind the scenes, this Chorma vector store creates an embedding for this question, and it will find the embedding that is closer to this information here. So we can comment that out for now. And the same thing will happen when we create a retriever. We're going to use our retriever to now retrieve the closest embedding that we can find. So we're going to now continue down here to perform our search, but instead of just typing the question here, we want to allow the user to create a prompt or to write a prompt from here. So you can, I'll keep this in here, but you can remove it if you want. Let's just keep that in here. And after the retriever here, we're going to check if, let's show a prompt, a chat input. So, but it's going to be our prompt. So if prompt, we're going to say colon equals st.chat underscore input and say prompt in here, then colon, and then we're gonna hit enter in here. Let's do prompt. This is the prompt that we're going to use. So once we save that, right, we process our file and then we show the user the prompt so they can start typing their question about the prompt about the file that we uploaded. Now we're going to take in the prompt. We're going to call the retriever. So we're going to say, okay, our docs underscore retrieve are equals to, I'm missing an E here, to the retriever dot invoke. So we're going to invoke our retriever with our prompts. So with whatever the user type in there. Now we're going to take that embedding, right? Or the embeddings that we retrieve, and then we're going to pass it to a prompt template. So now we are around here, right? We have the retriever. We are creating a embedding for the prompt. We retrieve the closer embedding that we can find. And now we're going to put the prompt together with the embedding that we created here, that we found inside of a chat prompt template. So here, what we're going to do next is to create a prompt template. And here we're going to use a chat prompt template, which we need to import up the top. So we're going to go back up to the top, and then we're going to import the chat prompt template. Let's see. Now let's do it. It doesn't matter. Let's do it here. Let's do from LangChain core. We're going to do dot prompts. We're going to import a chat prompt template, and then we're going to create the chat prompt template all the way at the bottom again. So we're going to scroll back down to here, and for the chat prompt template, we're going to create a system prompt, right? And then the system prompt is basically the prompt that we want to pass to be generated with the question, where we're going to pass the question or the prompt that the user is asking and the document. So we're going to pass the information we need when we invoke the prompt, the final prompt that will be generated. So here we're going to say system underscore prompt, and we're going to set that equals to a triple quotes here, so we can put a multi-line string, and we're going to say to the model, you are a helpful assistant and now we're gonna do dot, let's say, please answer the following question, and then here we're going to put a placeholder with curly brackets. We're going to say question, which is going to be our prompt. So we're going to pass the prompt again, and we're going to kind of like pass it in here. This is a placeholder for the prompt template, and let's say only using the following information, and we're going to pass the document in here, right, or the embedding, right? Let's just say document, right, because at the end this is the document that we retrieve, which is the most similar to the question that the user is asking. And then here we can say if you can answer the question, we just say you can answer that, or that you don't have enough information, whatever we want to write in there. So we just want to make sure that the model only answers the question with the information that we provide, right? With the document that we retrieve. So we basically telling them, hey, if you don't know, only use this to answer. If you don't know, just say you can answer that, right? So that we're trying to just keep it from using any other information other than the one that we're providing. And we can do more there, but for now, I think this will get us some good results. So let's now generate our prompt template by setting this equals to a chat prompt template in here. And then we're going to say that from messages, chat prompt template from underscore messages, right? No? Okay, there we go. And then in here, we're just going to put a list. So square brackets, whoops. And we're going to say parentheses, quotes system, right? This is a system message, comma, and then we're going to pass the system prompt that we created at the top. Now, this is a template. Now, with this template, we're basically just creating a template that we can pass the question that the user is asking and the document that was retrieved using the retriever in here, right? So we're going to now use this template down here. We can invoke it in order to get the final prompt that we're going to send to the model. Remember, we have two different models. We have the embedding models, which is the one that is creating the embeddings, and the Chorma is the retriever that retrieves the closest embedding that we can find. So once we have this final prompt, so let's say final underscore prompt, then that final prompt is the one we're going to send to our other model, the completion model, that is our GPT-4o-mini, that is going to create the response using the information that we provided. So here we're going to set that to prompt template, and we can use the .invoke method to invoke our chat prompt template. And then we're going to pass a dictionary here. And we just need to pass the information for placeholders. So for the question in here, so question is going to be just the prompt, right? So whatever the user is asking about. And then the document is going to be the document that was retrieved from here. So the docs retrieve, and we can just pass that in here. So the prompt is going to go into here. So if we ask in the same question, what is the main topic of this case study, this template is going to get this here as the prompt. So it's going to be, you're a helpful assistant, please answer the following question. I mean, in here, this is where the prompt is going to go, sorry. So, and the question is going to be, what is the main topic of the case study? And then it says only using the following information. And then we pass in the docs that were retrieved to here. And we're going to say that only if you cannot answer that, just say you can answer that. So that's a short prompt template. We can do more in there, but right now I think this is basically what we require in order to test this out and see how well it is responding. Cool. So let's take a look at the final prompt here. If you want to take a look, you can print the final prompt, and let's do a message this time here so we can find this. Final prompt in here. Let's go all the way down. We got our Chroma's IDs, but then we need to pass the file one more time. No, it is already there. What is it? Let me see. IDs right there. Oh, we just need to ask the question now. What is the main topic of the case study? Right before I hit enter, let's show where we are right now. So we basically, we console log the IDs in here. We create the retriever. The retriever is ready to retrieve some documents, but we're waiting for the user to type a prompt. So this only execute if we have a prompt. So once we hit enter, we're going to retrieve the documents using the retriever. We create a chat prompt template, and we're going to see how that looks in here now. So I'm going to hit send. And Chroma's IDs. Where is it? Where is it? Where did it go? Let's refresh it. Refresh. Make sure everything is working here. Okay. Find that again. Upload. Processing file. What was the main topic of the case study? Send it. Processing file. Okay, looks like we do have a little bug here. Let's see our IDs in here. So let's see what's going on. We have the prompt here. Now let's see. Let me copy this again. Okay, here we go. Final prompt messages. The final prompt in here. This is our last console log. Now it has a messages property here. It's a system message. And look how it reads. Your helpful assistant, please answer the following question. New line. What is the main topic of the case study? Only using the information, and here's the document that was retrieved using the retriever, and the information is in here, right? We don't need to do anything else. This is going to create this, and we can feed this final prompt into the model using LangChain, and it should be able to give us back a completion from here. Now, if we minimize this, we scroll back down, we have the final prompt in there. You can comment out some of these console logs if you want. I just want to show you in there how everything looks. So our final step, basically, let me see if we are at the final step. Because right now we are here. We created our chat prompt template. We have this augmented final prompt, which now we need to pass to the model. And the model is going to give us back the completion. So we're almost done. So now in here, after we print that, we're going to now, we need to create our model. We already have imported at the top the chat OpenAI, right? But we haven't initialized our model. So down here, we can say, we can initialize it at the bottom too, but let's just keep everything here now. So let's say this is our LLM model or our large language model. We're going to create a variable called LLM equals to chat OpenAI. And here we can provide the model we want to use. So I can set the model to whatever model you want. I'm going to set it to the GPT-4o-mini. You can try it out, different models in there. And because we already have, let's click on always rerun here to make sure everything is fine. And this is going to automatically look into our .env file and grab our API key, just like this one did. So we don't need to really provide the API key, just the models that we want to use. And then we can use this LLM down here to go and query or to invoke the model with our final prompt. So in this case, we're going to be reaching out to say create completion, because this is going to use the completion API. So we're going to say completion equals LLM dot invoke, and we just need to invoke it with our final prompt which has the prompt and the document with the most similar information that we can find. And now we can print the completion, and we can do a completion dot content in here so we can see what content that we have. And now let's see down here. Let's pass the same question, hit send. Okay, cool. Completion. In here, the main topic of this case study is the development of a hybrid recommendation system designed for an educational platform that aims to provide personalized learning experience for K-12 students in public school districts. Look at that, perfect. So using the information that we retrieve and we put it together with the prompt and the document that has the most similar information, running that similarity search, we have now provided enough information to the model so it can respond back with a completion of the questions that we are asking, right? So we can also see that in the UI by, let's see if we just do a quick, let's see, what can we do here? So actually, let's just stream the information here, because right now we already have the completion here. So this is the actual information we need to show the user. But if we stream it like by chunks, it will have a better UI. So stream, or let's say just streaming the completion results in here. So we're going to say, let's create a full underscore completion empty string here. So we can concatenate the different chunks. So when you stream the response, instead of waiting for the whole entire text to be generated, you can get the chunks of text that the model is generating. So we're gonna use a for loop to say that is chunk. So for each chunk we need to invoke the model again. So we're going to basically comment this out so we can keep it in there. And let's invoke the model here with a different method. So LLM and that stream will give you the streaming of the chunk. So we're going to pass the final prompt to this method. And then here we're going to concatenate to the chunks to full completion. So full completion plus equals the chunk that content in here. And then we just need to have a piece of UI that we can show the text. So we're going to need a container that we can write whenever we have the information here. So we're going to do a quick, let's call this results underscore placeholder. And that is going to be a sd.empty container that we can write to it whenever we have the information ready. So this is just a UI container. And then here, we just need to do, let's call this results placeholder.write method. And then we're going to pass the full completion. There you go. Go ahead and save that. And now we're going to, let's see what's happening here. Let's paste the same question again and hit send. Processing file, there we go. So that's streaming happening in there. Perfect. All right. So now we have put together this whole entire flow here. So let's take a look at it again really quick. So we have the loader. Now you know how to use document loaders. You know how to create different chunks using text splitters. You know how to create embeddings. You know how to store those embeddings. You know how to create retrievers to retrieve embeddings with the Similarity Search using the OpenAI embedding model and using Chorma. Now you can create prompt templates that you can put together and pass the information that they need, like the prompt and the embedding with the closest information that we can find. And now with that augmented or final prompt, you know how to send it to the completion API to get a completion and show the results to the user. So a lot of these different components that we use in here are going to help us build agents in the upcoming videos. So we're pretty close to creating our agents. So we're going to reuse some of these components from LangChain in order to create those as well. So this is a really cool application to continue using and deploy. So I got some deploying videos that you can watch again. I'll make sure to link those in the video as well. And down here at the end, before we pretty much finish up, our files are being kept in here. So we can delete those in here in a final. Let's go ahead and import. Let's add the tab. Let's have an import of OS. And we're going to use a final final block in here. We're going to say finally, colon, and we're going to say if os dot path, and we can use the path that exists. We're going to pass the temp file path that we created at the top when we were loading up the file. So if that exists, so we have this path, if this is there, once this is done, we want to now remove it because we're keeping it here because we're testing, You can comment this out while you're testing it out, but it's good to like remove the file. Or if you want to store those files in another database, it's up to you. But I just want to show you how to delete those once you're done with the questions, or the user's done with the questions. So we're going to use the os.remove in here, and we're going to pass the temp file path in here and hit save. Now those files will be removed after we're done. But again, you can just comment that out. So say it was removed after we finish up. Let's see if it's still working. Send the question in here. So the file is there, processing file, we got everything, and then it gets removed. You can comment that out while you're developing, and then you can put it back in once you're done, so you don't just store those files in the server here. And finally, let's just try to do a couple of more questions about the file in here. So let's open up the file one more time. Okay, so in here, you can try it out, ask question about this file, any other file. I see some names in here about different people or the author of these case studies. So I'm going to ask a question here. Let's say, who wrote this case study? And hit enter there. Processing file. I can answer that. Okay, so let's see. It doesn't have enough information. So that could happen. That is totally fine. Maybe the question is what needs to be improved, or my question, right? So we can see these are, let's see. Okay, so yeah, there's some names. It doesn't say the authors, but that's kind of like my question that was not probably straightforward. But we can ask anything else that we want in here. Let's see what else we can ask. Let's say, let's just ask like, how can AI impact students? Let's see if now we can answer this one. Okay, there we go. Let's say AI can impact students by providing personalized pathways for learning, supporting adaptive and individual instructions, blah, blah, blah. So now, okay, it was able to, sometimes the question, but this is good for the model not to answer without, specific information. So if we were not able to retrieve some good document here, then it should not be able to answer that question. So maybe there was no document that was retrieved. So if we tried that again, let's say, who wrote this case study? Ask the question again and see our console logs here to see if we were able to retrieve some information. Okay, so here, final prompt, your helpful system, only using the information provided. There's a document here, right? But this information is maybe the closest that I can find. So if we look at the information there, page content here, a research intends to promote responsibility throughout the paper. We aggregate individuals that can identify, use ChatGPT, Grammarly. So it finds some personalities, companies in here, but it's probably not 100% sure. So maybe we need to work a little bit more on the prompt that we created, because there could be some information here that could be used to respond, but the improvement could be done in here, right, on some instructions to the model, because this is, we're just saying, hey, please answer this using this question, using this information, and that's it. That's all we basically providing. So we don't really need this new line here, it was basically more for our eyes, but the model doesn't need that. But improvement on the prompt can help you, can help the model answer the question better. But pretty much this is the whole entire application. Again, we're going to continue building a couple of more, I think one more app, and then we're going to start creating agents. So keep working on the prompt engineering here at the prompt section. Deploy this app. This is all the projects that you can showcase for any job interviews or anything like that. And then we're going to start creating one more app, and then we're going to jump into creating agents. So hope you like this one, and I'll see you in the next one.